Welcome to my YouTube channel, Christy's Crash Course. Today we are going to start a very new and different series on pathology. We are going to be talking mostly from the textbook called Robbins and Kumar Basic Pathology, and we are going to be handling chapter by chapter. We're going to obtain most of the informations from the basic pathology textbooks and hopefully explain the most critical matters enlisted in the textbook. So for today's topic, we are talking about cell injury, cell death, and adaptation. What are we going to look at here? Now, we are going to look at the definition of the concepts of cell injury and cell death and adaptations. We are going to look at what is cell injury and disease, what are the causes of cell injuries. We are going to explain most of the causes, how do these causes play a role in ensuring cell injury or cell death. We're also going to look at the mechanism of cell injury. So how does it occur? Yes, we know that there are causes, but then how do these factors play a role in the intracellular makeup of a cell to distort its function or its structure? The next thing we're going to look at is what are the adaptations that a cell naturally wants to undergo when it is being threatened by these injurious stimuli. We are also going to look at a very interesting phenomenon, which is if the adaptive capacity is exceeded or if the injurious stimuli is inherent, then irreversible cell injury will occur. And in that case, we are going to then look at what really is irreversible cell injury, and then we are going to look at apoptosis, and we're going to end it with intracellular accumulations. A lot to be talked about, a lot to be looked at. We're going to try to explain bit by bit as you come along with me. Hopefully you get to understand it, and if you have any question at the end of the video, please leave your questions in the chat box. Please do like, please do subscribe, and hit that like button. All right, let's go along. Basic definitions we are going to be looking at right now, they include what is pathology, secondly what is etiology, thirdly we are going to be looking at what is pathogenesis, what is homeostasis, what is reversible cell injury, and definition of the concept of necrosis and apoptosis. First of all, we are going to go with pathology. Pathology is a field of medicine that is dedicated to the understanding of the causes of a disease, of the causes of disease and changes in cells, tissues, and organs. So the field of pathology is very crucial for medical sciences, not just because we're going to know what is really causing this disease that this person is undergoing, but we're also going to understand genuinely how it is affecting the cellular makeup of a person. And you may ask, oh, but why are we really considering the cellular makeup? Because remember that we are made up of cells. Of course, our cells, we have our nucleus, a very important structures. We have our endoplasmic reticulums there. We have a lot of lysosomes and all of that going on here. We have our mitochondria here, right? So this is a very irregular view of a cell, but then a group of cells comes together, and when they come together we get to see the concept of what? Tissues, because tissues are group of cells connected one to another via junctions. And then when group of tissues, so group of cells forms tissues, and eventually groups of tissues give rise to organs, right? So group of tissues comes together, and so you get to see something like the pancreas as an organ, right? So you get to see different tissues going on there. You get to see epithelial tissues are there. You get to see connective tissues are also there. You get to see the presence of nervous innervations going on there, right? All within an organ. So group of tissues, organ is simply group of tissues coming together gives rise to an organ. And we have group of organs will eventually give rise to what? System. So this is the basis, that group of organs gives rise to systems. And we're going to explain what we mean by that. We mean that when you are looking at your digestive system, you have group of organs. You have the pancreas is part of it, although it's an accessory, right? You also have the stomach, you have the small intestine, right? You have the large intestines. Okay, so group of organs gives us systems, and then eventually our group of systems forms our organisms. And we are organisms. We are living organisms. And so pathology is that field of medicine that does what? Is that field of medicine that enables for us to understand what really is causing a disease, right? So someone has cancer, or someone has a condition of the kidney. We want to know what is the cause of this disease, and then we want to understand what is going on in your cell, because if we can understand what is going on in the cell, we can understand what's going on in the tissue. And so if we understand what's going on in the tissue, we can also see what's going on in the organ, and we can get an understanding of what we need to give this person to help the situation. And so that is why pathology is very critical. Now we've defined pathology. The second thing we need to define is etiology. What really is etiology, and how is it important? Now, etiology is dealing with the origin of a disease. So etiology is literally us finding out what is the underlying cause or the underlying factors responsible for this disease. So etiology is the discovery of the underlying cause or factors of a disease. And then what of the next one that we have to define? So we have pathology defined, etiology defined, and then the next one we have to define is pathogenesis. What is pathogenesis? Pathogenesis refers to our steps in the development of the disease. So from the initial trigger point to cellular development to molecular changes going on in the cell, pathogenesis addresses the development. How is the disease progressing? It started at this point, but it is going to this point. That progression from point A to point B, this progression of disease is called pathogenesis. So, to define it much more accurately, pathogenesis is defined as the study of the progression the progression of a disease. Okay, the next thing we have to define, so this is the second thing we are defining, and then the first thing we defined was, okay, so pathology was the first, etiology was the second, and the third thing we defined is pathogenesis. Perfect. The next thing we have to define is, so we've looked at pathogenesis. The next thing we're defining is homeostasis. Homeostasis in very basic form is simply the maintenance of a steady internal environment. It's the concept whereby your body does what it needs to do in order to keep you at a constant internal environment. And so in a situation where the weather outside becomes really cold, your body wants to generate heat enough internally to keep you warm. It is what your body does in order to maintain that constant internal environment. So your body is undergoing changes at every point in time in order to maintain a proper functioning environment. So how do we define homeostasis? Homeostasis is the constant adjustment of structures and functions within the body in order to accommodate changing demands to maintain a steady environment. Homeostasis is the constant adjustment within the body in order to accommodate the changing demands of the body in order to maintain a steady state internally. So this is our fourth definition. So the first definition is the definition of pathology. Pathology is a field of medicine. It's dedicated to the understanding of the causes of disease and changes in cells, tissues, and organs. The second one is etiology, is the discovery of the underlying cause or factors of a disease. And then we said pathogenesis is the study of the progression. Some will say it is the study of the development of the disease. And then we have homeostasis. Homeostasis is the constant adjustment within the body in order to accommodate the changing demands of the body in order to maintain a steady internal environment. Now, that being said, we are going to also go further to understanding the next concept. The next concept we have to define is reversible cell injury. Reversible cell injury can be defined as the derailment of functions and morphology that a cell can recover from if a damaging stimulus is removed. So, reversible cell injury is defined as the derailment of structure and function that a cell can recover from if the injurious stimulus is removed. The next thing we have to define is the concept of necrosis and apoptosis. We have heard maybe before the concept of apoptosis, Hopefully we've also heard the concept of necrosis, but then how can we define it according to a pathological standard? What is necrosis, or what can we also call or liken necrosis to, and also how do we define apoptosis? All right, so apoptosis can be defined as the pathway of cell death in which the cells activate enzymes that degrades the cell's own nuclear DNA and nuclear and cytoplasmic proteins. So I'm going to explain it, but we have to know the professional definition. Apoptosis can be defined as a pathway of cell death in which cells activate enzymes that degrades the cell's own DNA and nuclear and cytoplasmic proteins. Okay, it is also known as programmed cell death. It also known as programmed cell death. Meanwhile, the definition of the concept of necrosis is also known as necrosis. It's also known as accidental cell death. And necrosis is a situation whereby the cell has a leakage of its cellular component and it digests itself. Okay, so in the words of Robbins, necrosis involves cellular membrane falling apart, cellular enzyme leaking out, and ultimately digestion of the cells and accompanying inflammatory reactions. So necrosis, please pardon this part of the introduction. It might not seem all interesting, but it's necessary that we get these definitions out of the way. Now, necrosis is also known as, accidental cell death, and it is characterized by three major events. The first one is cellular membrane falls apart. The second is there is a leaking out of cellular enzymes, which ultimately, so cellular enzymes leaks out and ultimately digests the cells. And the hallmark of necrosis is the presence of inflammatory reaction. Okay, so although we will get to understand the real concept of necrosis and apoptosis in later explanations, I just want to give us a mental framework of what is happening during the concept of apoptosis and necrosis. This is cell A, this is cell B, right? So we have a cell here, we have our endoplasmic reticulums here, probably we have a Golgi apparatus also here, right? So this is G, this is E, R, this is the nucleus, right? So we have lysosomes here and every other thing happening. So these are bilayers here, and same thing is happening for this cell. Same thing is happening for this cell. So what do we need to know about necrosis, and what do we need to know about apoptosis? Well, for the concept of apoptosis, we don't want any inflammatory reaction. So one thing that happens in apoptosis is that there is no inflammatory reaction. No inflammatory reaction. Why? Because it is a very programmed. It is planned by the cell. It is a planned death. It is a planned death. And so, since it's a planned death, it will require a lot of energy. It requires energy, and eventually the end product of apoptosis is being phagocytosed. So usually we call them apoptotic bodies are phagocytosed by phagocytic leukocytes, right? So phagocytic leukocytes include so just for emphasis sake, phagocytic leukocytes. Remember that leukocytes are also known as white blood cells. Phagocytic leukocytes include neutrophils. It also includes more so macrophages. And just as a side note again, remember that when you're in the circulation, right? So assuming this is your circulation, we have these cells which we call mononuclear cells, which are monocytes. Okay, monocytes. However, once the monocytes leaves the circulation to where tissues are positioned, they immediately change to macrophages. So in the circulation, macrophages are called monocytes, but then when they leave the circulation to the tissues, they are called macrophages. So that is what happens in apoptosis. However, during the concept of necrosis is actually something that will happen in our everyday life. For example, you're just walking down the stairs and you hit your leg or you bruise your leg against the stair. This is necrosis happening to your tissues, because remember, just under your skins are usually the epithelial tissues, and then remember that tissues are a group of cells. So that cell is actually undergoing necrosis because the death it is being subjected to wasn't planned. This is something that just happened because of a little carelessness, or just because of chance just happening to someone, right? So necrosis happens on a daily basis, and we say that it is actually unplanned, or more so we say accidental. And so because it is accidental, we usually have these three phenomena happening. And we said, first of all, the cytoplasmic component are spewed out. Why does this happen? Because the cell membrane is altered and not intact. So this is first thing that happens. Secondly, due to the process of necrosis, which will explain what happens during the process of necrosis, we get to see the second thing that happens here is that the lysosomes, which are organelles found within the cell, have hydrolytic enzymes. And during the process of necrosis, the membranes of the lysosomes are also being tampered with, and so eventually the lysosomal contents are emptied into the cytoplasm. Okay, and then finally, when we have the cytoplasmic components are spilled out because the cell membrane is being tampered with, we also have that the lysosomal contents are also being released right into the cytoplasm, destroying other proteins within the cytoplasm, and eventually also destroying the phospholipid bilayer that makes up the cell membrane. Eventually, since the cell membrane is ruptured, it attracts for inflammation. So simply put, that it attracts our host immunity to check out what is happening there. So these are some few things that occurs in the process of necrosis. We'll look at them much more deeper in the coming slides. But then we've defined pathology, we've defined etiology, we've defined pathogenesis, we've defined homeostasis. We've also seen that reversible cell injury can occur because it is simply the derailment of function and structure that a cell can recover from once the injurious stimulus is being removed. We also define necrosis, seeing that it's called accidental cell death, and we show the three major hallmarks that occurs during necrosis. And we also said that apoptosis is a more programmed cell death. It requires a high level of energy. In apoptosis, we have a more organized way of doing things, and more so in apoptosis, we do not want inflammation to occur. We do not want our immune system to come to the site of damage. We do not want cells to release any signals that will attract our immune system. And remember that the signals our cells can release could be cytokines, right? Debris is found into the circulations can act as signals that could contact our immune system to the site of damage. We do not want that, and so we wrap every part of the cell needed to be damaged in a certain body called an apoptotic body. Now, since we've gotten our definitions straight, we are going to now go further to understand what is. Okay, so literally, what is cell injury? I think we've actually defined it here also, and a bit of disease. So we are going further to understand what are the causes of cell injury, what literally can cause cell injuries, what literally can cause this process of derailment of functions and structure of your cell. What really causes it? Do our cells just decide on their own to go bad, or there's a stimulus, there's a situation? For example, we mentioned the heart kettle. How do we categorize a heart kettle in the explanation of an injurious stimuli? So stick around, because we're going to explore the causes of cell injuries.